Hey gang, it's me, John Frazzaro. So you have tuned in to watch the video of my talk, Make TDD Make Sense, Cheaper Changes Through Better Boundaries, as presented at Agile and Beyond 2024. The reason I'm talking to you now is that I was a dunderhead and I forgot to hit record until a couple minutes into my talk. Luckily, the only thing you missed was my little song and dance about who I am and why I'm talking about TDD. So I set this up by saying, for as wonderful and effective a development technique as test-driven development is, I continue to be shocked by the lack of adoption, the lack of uptake in our industry. But I think I've pinpointed three distinct problems that are causing that lack of adoption. So here we go. The first is that we often demonstrate it with toys. Code, like toy code that doesn't really do any work, any real work. And this makes people think that TDD is not for code that does real work. Second problem that I see is that code written without test-driven development, when let's face it, that's most of the code out there. Code written without test-driven development has boundary issues that make productive TDD in that code impossible. And this makes people think that productive TDD is impossible. And the third problem is that we start teaching it from the wrong end. How do we always introduce TDD? Well, first you're gonna write a failing test, then you make the test pass, and then we're gonna clean up the code a bit, and then we're gonna go do that again. Like if you're talking to a developer who's been at least nominally successful in writing code for like 15, 20 years, and you start walking them through this, it's like, for them, it's like taking a shower with their socks on. It's weird, it's uncomfortable. So you've got to find a way to motivate them. How do we motivate them? Well, we tell them this story about how you're unprofessional if you don't do TDD. You're just not doing it the right way. You're holding it wrong. This makes people feel bad. Does TDD feel bad, those of you who do it? TDD doesn't feel bad. It feels awesome. It's like a dopamine factory for me. And so I think we've got to address these three problems mostly in the way we're making people feel about TDD. We're showing them the wrong end first. I want to address all three of these things today, but I'm going to start with this last one. Here's like the real story that I want to tell about TDD. Okay, so I've got an app. Let me see if I can bring up okay. So this is a working application. It's got a back end with some data. And you notice what I want you to focus on first is that there's this greeting. There's this pleasant user experience. It knows what time of day it is, and it just gives you a greeting, okay? And that's happening just right in this main app code, this app component right here. And if we scroll down, we can see the greeting and, oh dear God. Oh no, which one of you did this? This code, you're fired. This code is objectively awful. So I think I'm going to do something about it. I'm just going to start using some of the tools here to refactor, to simplify that. I'm going to reverse, I'm going to flip this around. There we go. Actually, you know what? What am I doing? It's 2024, and I've got GitHub Copilot. So I'm going to highlight this function. Oh yeah, trackpads. Okay. And simplify. Just going to get the robots to do it for me. It's a lot better than it was. What do you guys think? Should we take it? Please, I'm going to give it a little bit of a nudge here. Please remove. It's doing such a nice job of explaining it to me. I'm being really rude. I'm just already moving on to the next thing I wanted to do. Someday I'm going to learn to be nice to robots. Please remove the braces on every if block. and remove. Oh no, that's worse. That is way worse. Okay, we're gonna go back here. Yay. Okay, so I'm gonna pop that in there. And there's definitely some other stuff I would clean up about this, but not bad for a couple of seconds. I'm gonna get rid of this nonsense comment up there. Okay, then I'm gonna switch back to my terminal where my tests are all green. So now what I'm gonna do, sight unseen, I'm not even gonna pay much attention to this, but I'm gonna ship this. There, committed. And this isn't some arcane pull request process where somebody's gonna review this 3 or 4 days from now. This is going straight to production. Okay, that is the story we want to lead with test-driven development. So, how many of you can work with code at your job like that? All right, got one. Awesome. How was I able to do that? Was it Copilot? Was it the miracle of AI? I mean, yeah, that's pretty snappy. That's what you saw. And also, JetBrains tools have incredible refactoring. It's on a completely other level. If you've only ever done stuff in VS Code, try out WebStorm. It'll blow you away. But all of that, refactoring tools, AI, all that stuff, that's the tip of the iceberg of what you saw. Okay, what I did to that code in just a few minutes with the confidence to ship it straight to production, that was only made possible by that code having been written in the first place using test-driven development. This talk is a couple of years old, and a lot of things have happened in the last couple of years. And when I dusted it off and tried out my demos with AI, I had to confront a few things and figure out what I wanted to say about it. So this is my reaction to AI-assisted programming. All of these people together, the multitudes in my head have this, mostly disgusted, somewhat shocked, and really the one guy that's my fetish. This is all happening in here. So does AI make TDD obsolete? That's the question. I want to talk this through. I want to explore this a little bit. How do you feel about generated code? Does it work? Will you paste it right into your app and ship that to production? No. It might work. It's a lot faster than typing. That's pretty cool. It was created by a word calculator. That's pretty neat. But you don't trust it yet. It might work. It might compile, right? Okay, so now what if we talk about generating tests? What if we generate tests for the code that we just generated? Will those work? Maybe, right? But you don't trust it. And if we generated code and then we generated tests for that code, that's not TDD. That's unit testing, maybe. And what sets test-driven development apart, that failing first and then making it pass, that's a trust exercise. That's a verification exercise. And that's what makes it different from unit testing. And so until we see the machine actually going through that process and somehow transferring that trust to the humans operating it, we've still got quite a ways to go before we talk about AI replacing test-driven development, that specific process. GPT and Copilot, those are, like I said, they're word calculators. They're not compilers, and they're not programmers. And they're not reliable, accountable actors in the way that we would need them to be. And they're getting more sophisticated every time I touch it, which is cool. I don't know yet if we'll ever get there, though. It seems like sort of an asymptotic thing. We're going to get closer and closer, but we're never going to quite cross the line where we can instantly trust what the machine is giving us. Because the problem fundamentally, I think, remains the same, is that code is soft by definition. It's software. You're supposed to be able to change it. It's supposed to be a little wiggly. And so you don't trust it. You trust, but you verify it, right? Trust, but verify. I don't know if you guys are old enough to get this reference. It's a little surreal for me because this is the guy that I grew up, my dad would yell at the TV the whole time whenever this guy was on. Anybody else have a socialist dad? Just me? Okay. So verify it quickly and often. Quickly and often. That sounds like a job for code, a job for a computer to do, not a person, right? And that's what micro tests, the kind that come from TDD, that's what those are for. And we're through the process of test-driven development, we pit code against code in a sort of, it's like double entry accounting, right? You do it over here, then you do it over here, and when those guys line up, you're good. Anyway, so we went from a mess to a lot more readable than that initial mess. And we were able to do that and ship it, and be done with it quickly because we trusted it, because we had tests written using test-driven development. Okay, I think it's glorious, but some of you might still be saying, so what? Clear code, I don't care. That's fine for Fazaro, that's fine for XP nerds, that's fine for whoever, but I'm a pragmatic programmer. My code doesn't have to be clean, it just has to work. My boss doesn't care that my code is clean, why should I? And professionals can read messy code. That's what the money's for. So why would somebody who didn't necessarily care about the beauty of code aesthetically, why would they care about this? So obviously there are tests for this. This is what they look like. Okay, and what I ended up, the backstory to me coming and refactoring that code really was we have a user story that, well, a lot of our users use the app during their lunch break. So they want a lunchtime specific greeting that kind of makes them feel seen and all the sort of fuzzy feelings like that we want to bake into the app. So here's the user story. If it's between noon and 1, I want it to greet them for lunch. So I'm going to add a test scenario to do that. So at 13 o'clock, at 12 o'clock, I'm going to say, enjoy your burrito. Okay. It fails. It expected enjoy your burrito. We got good afternoon. Let's go make that pass. Oh, these are terrible. Okay. So I'm going to copy these two lines, I think. And then if it's before 13, then I'm going to change this to enjoy your burrito. Test pass, and I'm going to ship it again. Feature, lunchtime. Okay. So, again, hands up if you can work with code like this at your job. Can you come in and clean something and then maybe within 5 minutes implement and ship a user story? Dustin can. Some of you at this point might be asking, is it possible to learn this power? And again, the Star Wars nerds of you you're ahead of the rest of the room because you're already answering not from a Jedi. But that's really just because Jedi are made up. But software coaches are real. We're here for you. Let's talk about architecture. Who's heard this? TDD leads to good design. Okay. Yes, but like at gunpoint. TDD doesn't lead you to great design if you don't understand what makes a design great, if you don't have the skills and knowledge to implement a good architecture in the first place. The relationship between TDD and good architecture is that TDD just breaks. It won't work when you have bad architecture. It doesn't lead to anything except to people not doing TDD because they tried it and it didn't work. So this leads me to clarify this with the slightly less catchy, when TDD is hard, it probably means your code doesn't have a good design. And that's useful, but we should remember that it's not going to create a path for you. It's just a signal that you've got something broken in there that you need to address. In terms of addressing this problem with code that's not toy code, and also kind of getting into the code with boundary issues. And I'm going to use React as an example. Anybody use React to build web front end? Awesome, perfect. Okay, so now this example is in React, and which is a web front end framework, but this could apply not only to other web front end frameworks, but mobile apps, stuff on the back end. This is the idea that I'm trying to convey is not specific to the type of code that I'm showing it in. This is just a handy example. So like most UI frameworks I've used, React features two types of code, declarative and imperative. Are these familiar words to anybody? Okay, so declarative code, it's like your markup, right? The placement of code, a line of code in the file indicates like it maps to placement on the screen, spatial placement, as opposed to imperative code, where if a line of code is somewhere in the code file, it means something about sequential execution. This is most of the code out there that when we think about code, we usually think about imperative code. Unit testing and TDD make a little more sense for imperative code because it has behavior and state changes and input and output that happen over time, which is harder to hold in your head and reason about, and so you want to kind of anchor that by having good tests. If you have unit tests around declarative code, it's a little more like, hey, is the button green? Yes, the button's green. It still has that double entry accounting. It still locks things in, but it feels a little more rote, a little less valuable. And an important thing, you probably have seen this, those of you who've developed in React or worked with declarative and imperative code, you want to try to keep them separated because that's easier to maintain when they're properly, bounded and they just sort of interact with each other in a very straightforward way. But what happens as you are pressured to deliver sooner and maybe you're tired one day, your code starts to look like this. You get the peanut butter in the chocolate and not in like a good way. There's some declarative code, and then all of a sudden we break into an inline function where it's imperative, and then back into declarative. They get mixed in together, and the next thing you know, you've got a toilet in your kitchen. Do you guys know there's like a shocking number of pictures of toilets installed in kitchens on the internet? I don't know if here's another one. This one actually better illustrates my point because we've got even more stuff in the soup. It really conveys the feeling of when I go into a code base and I see all these things mixed together. The funny thing about this is it's not actually a terrible idea from a plumber's point of view, right? So a plumber gets to okay, I'm going to do all the work in one room. I'm going to wire this thing into that thing, and I don't have to walk across the house to make sure that when I flush the toilet, it doesn't explode the sink or something. They get to, and that's the same force that causes us to mix the different types of code into one file, into one place. And causes us to have bad boundary issues. And if building a house was anything like building software, which it's not, you've heard terrible analogies about this, no doubt, but it's not, because if building a house was like building software, the plumber would in fact be able to build the toilet and wire it up in the kitchen and get everything working with the sink and and all that, and maybe the shower too. And then after he verified that everything was working, he'd be able to refactor it over to the other side of the house, right? And while people were living there, without moving their stuff out. That's what software can do, right? You don't have to get people's data out of the app to upgrade it, right? So there's something very different about software, and it's okay to build the thing that way. Just go the extra step to separate it. Do that refactoring before you call it done. To bring this back to React, a React component is sort of it's a vertical slice of user interface, right? So it's like you took a cookie cutter and took a chunk out of the screen, but everything like the markup and JavaScript and API calls and everything, it's in there, in the component. And so you've got imperative code inherently mixed in with declarative code, even if you keep them well separated to their own sections of the file, it's still in one component. And the unit testing wisdom generally that I've seen out there on React is test the component from the outside. But that sort of puts you in the position of testing more than one thing at once. And that pushes against what's good about unit testing, which is that you're testing one thing at a time. The more things you try to test at once, you get more coverage, but you also get more variables and elements in the mix, and it becomes less deterministic, which makes it less stable, which makes it less fast, which makes it harder to hold in your head and reason about, and it kind of breaks TDD. And so test driving React has been a particularly interesting challenge, and I think I've got something, I've got a pattern that works for this that I kind of want to share. Okay, so I just want to show you where we are in the app. So there's this app keeps track of projects, and it's just got a form where you can sort of update details about the project. We are going to be looking at the component that entails that form. And of course, we've got tests for it. So this is a component called project form, and as I kind of described, it's got all this imperative code, lots of sequentially executed things, functions and stuff. And then starting at the return, we've got all the declarative code, all the markup from there down. Okay, and the tests for it sort of look like this. I'm using sort of a BDD style of naming, so it's got lots of nesting, given when scenarios, so it's actually kind of readable. If you read this tree of test names, it'll pretty well describe the behavior of the component. And so what I want to do is I want to add a field that represents the date that the contract was signed on. And this field already exists in the underlying data, it's just not on the form yet. To start with that, if you look at the tests, we've got this core function this is kind of called in a before each, that's run for every test. It actually renders and mounts the component in a test harness, and then you kind of use a screen scraping sort of mechanism. This is with testing library, the best named testing library that's out there. And you sort of grab onto these elements and you start interacting with them sort of in a simulated user way from the outside of the component, full stack. So if we're going to add a new field, I guess we should start by trying to find that field in the component. And of course we won't because it doesn't exist yet, but let's see, signed on date input. And then I'm going to look for the field with the caption contract signed. Okay. Ignoring the compile error for now. Okay, all kinds of things wrong with that, but the main one is that it can't find any such component. So I'm going to fix that compile error, but then I'm going to go down to the markup. I need a label and an input in order for that to work. So I'm going to call this contract signed on, and then I need an input with that ID. Contract signed on. I have to actually put the text in the label because that's what it's looking for. Okay, so back to passing. I'm going to move this line of code to where the other things are defined so that that's available in the other tests. The next thing I want to do is verify that it's going to load the data into the form. So I'm going to grab this. This is the test project data, and it's got a contract signed on date. I'm going to grab that, and in this test is for loading it into the form. I'm going to add that field and assert that that field is there with that value. It is not. So the next thing I've got to do is make that field, the input's name, match the data that gets loaded. Okay, so it's got the field now, it just doesn't have the value. So then I set the value as project contract signed on. Now that test passes, but then I have this rash up here, and it's complaining that I have a value attribute without an onChange handler. So I'm just going to stub out the onChange handler so that rash goes away. Okay, so we've got a field now. Now what I want it to do, when I want to test next, is that it interacts. It updates the state of the component when we change that value. And there's several other tests that are doing things like this, so I'm just going to kind of copy and paste to get started there. This is basically like the description. So I'm going to copy and paste the description tests and then change them to match this. And then let's say it's the first of the year, like that. And I'm going to update this and the expectation, expecting that value. Okay, let's see if this. Okay, does not pass. It's got the original value in there, and that's because we didn't do anything on change. So now I can just pass that off to this handle change function, which is also wired into all the other inputs. And that passes, but again, there's a rash. Component is changing controlled input, likely to be uncontrolled, some weird stuff. Value prop on input should not be null. Okay, so I think this is coming down to this is sometimes null and it wants an empty space or an empty string instead. Okay, so there's sort of this awkwardness to kind of testing it from the outside. It is starting to work. I've still got sort of a test-driven development flow, but I find it feels like working on a ship in a bottle, right? So if I want this to submit the date in a certain format, for example, I have to go sniff that this function was called with the right data. Here, I'm testing the onSubmit, and I want this to sort of change the format of the date so that it's a full ISO date, because that's got to be sent up the API. And I want it to look like that when we click save, but it doesn't. Let's see. It expects this, but it's getting just the date as typed because it's just a text box right now. Okay, so the next thing I'm going to do is I want to change this to a date type input, kind of getting at this is eventually going to get reformatted and stuff, and everything breaks because it's looking for a text box. In that the first aspect of the test that I added there is screen get by role. So it's looking to grab onto that control by text box. And I looked into this. There is no ARIA role for a date input. This is like a hole. I think it's actually a hole in the specification, not even just in the implementation. And I didn't go too far down that rabbit hole. I'm not an accessibility expert, but I find it a little, I don't know what the answer to that question is, because don't people with screen readers pick dates? I don't know. It's weird. Anyway, the fundamental problem here, though, in relation to what I'm saying, is that this makes test-driven development like taking a shower with my socks on. I'm trying to get at the imperative code up in the top of the component, but I have to do it all through the markup and all of the quirks of the markup that come along for the ride. Again, this is sort of what we saw. This is the testable unit, is all of the imperative code and declarative code together. The solution that I have for this is actually to factor out the imperative code by extracting what in React terminology is they call it a custom hook. So we're going to extract all of that, everything above the return, into a custom hook. And then there's ways for us to test the custom hook directly without involving the component. And then the regular component, we lose a little bit of coverage because we don't involve the markup in the test scenario. But this helps with TDD because we're going to have a much more straightforward interface in working with that hook. I'll show you what that looks like. First, the refactoring. I want to show you this because it's pretty cool. I've tried this in VS Code and I've tried it in WebStorm. It only really works in WebStorm. I'm going to highlight, starting just inside the function, just inside the component, I'm going to highlight all of that. Oops, that was a little too much. All of that imperative code right down to the return. I'm going to do an extract method and extract it globally to the file. And I'm going to name that use project form. So the pattern is use and then the name of the component. So then you sort of get, it's almost like a view and view model architecture. And so I've got this use project form function now it's got all of that code just as it was, but instead of returning markup, instead of returning angle brackets, it returns a plain old JavaScript object of properties and functions, which is going to be much easier to interact with from a testing standpoint. And then we've got the component down here, which merely invokes the hook at the top and then goes straight into its business rendering markup. So the final step of this refactoring is going to be to notice the tests still pass. I also want to move this to its own file. So I'm going to move that just next door to its own file. See, this is the WebStorm stuff. It lines up all of the imports correctly and just everything comes out clean and the tests don't break at any point. So it maintains my trust in what's going on. It's important. Anyway, so we've got two much shorter files, much more focused on things. The tests, however, as you saw, they're still testing the component from the outside. So through the miracle of switching branches, I'm going to take us to a parallel universe where we started that way, not refactored into it. You can refactor into it and then sort of gradually add tests that address the hook directly, but that's not what I want to do. All right, so this is the universe in which we have both tests on the component and tests on the hook. I'm gonna change this a little bit so we're just running the tests on the hook for now, so we can focus on that. So again, here's the hook, and actually in this parallel universe, you'll notice the code is just a little bit cleaner because we've been test driving this and refactoring as it's gone. There's not a giant handle change method. There's just sort of individual, do the change for each field. That design sort of emerged from so this points to test-driven development isn't a testing strategy, it's a development strategy. It will actually change the code that comes out if you're able to follow it. So the tests for this, I want to start with that core render. Remember the render function from the other tests actually mounted the component and you saw markup in there. And then we had to do a bunch of screen scraping to get a hold of the things that we were going to use to test. Not the case with this. We just have a single render hook function that comes from testing library. We pass it a lambda to execute our hook, and then we've got the result. And the result is sort of, it is still, you still need to use the render hook. You can't just like call the function directly, because using render hook actually puts it into the React sort of life cycle and gives you realistic stateful behavior as you would get it from a custom hook. So it's accurate from a testing standpoint. So the first thing I'm going to do here, rather than, I don't have to screen scrape to find the new field I want to add, I just sort of start asserting that data is in there, because I can access the state directly. I'm accessing the project specifically. This is the project object that's in state. And of course it already has the contract signed on date in it. That doesn't tell me anything about, whether the form has a field on it. So where I'm going to start is sort of halfway along where we were earlier, in what happens when you change the field. So if we change the signed on date here, I'm just going to get rid of those, and that's going to be subject. Sorry, I named this test subject. This is what's coming out of there. And then I say current, meaning that's the representation of the current state of that hook. And I'm going to call a method called change signed on date. And I'm going to pass that value in we had before, the first of the year. Okay, and right away I've got a problem because signed on date isn't a thing that exists. So here we are in a natural sort of TDD flow where I'm going to go make that function exist now. Okay, much more straightforward. And I've got to change the expectation here that contract signed on the project has been updated to this value. And of course it hasn't, because that function doesn't do anything. So what I'm going to do is I'm going to kind of mimic what the other update functions are doing. Contract sign on, and then I'm going to need a value passed in there. Whatever gets passed in gets assigned to that field. Okay, and we're passing, but there's a rash that's kind of warning me about the way I'm interacting with the component, or with the hook. So for that, I'm going to have to surround it with the act helper method. This comes from testing library again, and it's sort of anything that modifies the state of the hook or component has to be inside of an act. So it's warned me about that, and now we've got a good test that's passing, and we can proceed from here. Sorry, got lost for a second. I wanted to refactor this into, undo. Refactor that to a named function. Name's good. I'm going to collapse that to the short notation and then move that guy up there. So pretty quickly, we're back into a more familiar imperative only kind of TDD flow with React code. And then when I'm ready, when we've established the behavior in the hook, then we can come back here and simply just wire it up in the form, in the markup. And if you want to add tests that test that stuff, you can. I find it a little less valuable than getting the behavior under test. I tend to leave markup, and wag your finger at me in shame or whatever, but I'm always thinking about, like, is this giving me a return on my investment? And always with imperative code, not always with markup. So anyway, just to kind of wrap up what I'm saying, when you hear somebody like me going on about TDD, they're not crazy. It works. But also, when you hear somebody complaining or poo-pooing TDD, saying that it doesn't work or it's hard, they're not wrong. At least they're not wrong about how much suffering there is in trying to make it work in a code base that's not ready for it. And there's a prerequisite there that's not being met. But it can be done, and it's worth getting into the architectural problems that TDD is signaling to you that are there. because it is still, even in the age of AI, it is still the fastest and most solid way to write code that I know of. So in my head, I did it. I made TDD make sense. Kylo seems happier in my mind. But like I said, Jedi and Sith, that's all made up. And what matters is y'all. So did I change anybody's mind? Did I do it? Did I make it make sense? Any questions? Thoughts? Yes?
So this really comes down to like a mindset, right? And what's important to an engineer, like your craft. It seems like so. What have you found that can help people with maybe like no, this isn't. Why would I do this? This is extra work. It's hard. What have you found to help kind of get them to maybe change their perspective and move a little towards that?
One of the problems with TDD and with, I think, anything under the heading of lean and agile in the large is that the benefits are on the other side of the thing you have to do first. And it's hard to work through something that, well, first of all, learning something new is inherently slower, right? So you have to get them through that learning curve. And that's what I was talking about, like, let's motivate them by showing what it looks like on the other side. We have to find a way to like show what the result is, the real result, not just you're better at this now. I mean, not just you're a craftsperson now, badges are fake, but delivery is real. Show them what it looks like when it's working. I think that's the best thing you can do. I mean, some of the most successful like organizational transformations involved a field trip where the leaders from one company go and visit a company and see it viscerally, firsthand. This is what it looks like when it's going, when it's working. Not just here's the textbook, start studying. Yes?
I found it helpful to start with like doing bugs where you reproduce it with a test.
Yes.
And then go, have you found that to be like a good way to kind of approach organizations to get them?
Yeah, that's a very good. It's good in that it's small. It's good in that it's one of the sort of in the Venn diagram between things that make sense to developers who do and don't do TDD. It's right in the middle. It makes sense, even if you don't do TDD, to write a test to make sure a bug doesn't recur, because everybody's had the problem where a bug recurred. That's something in their life experience that you can tap into. Yeah. Yes.
For one, trying to apply test-driven development on a larger application. I think part of the challenges that I have is emergent properties, right? I might have 5 or 6 different little units or things that it does, but then there is this emergent property that, as you combine them all, that comes out.
Yeah.
And the customers really depend on that. And then it's hard from the small to the large to see that emergent property and to kind of test toward that emergent property.
Yeah. Yeah. So that brings me back to test-driven development is not a testing strategy, right? It's you build your code using unit tests and test-driven development, and that puts your code in a certain flexible condition. Also implement the rest of the testing pyramid as you need to secure the behavior, to hold things still. And then when you discover something's wrong, this code is that much more flexible because it's been,
Right, but then you have these components. But as you learn the system and you discuss with the customers, the components can also change. So at some level, you have some component in your mind, but as you adapt and understand and learn, those components change, and all of a sudden your testing is kind of off step, right?
Yeah.
From where you want to take the product to go. So
Yeah.
You almost have to refactor how you're doing your testing.
You do.
Yeah.
Yes, because it's made of code.
Yeah.
Yeah, you have to. Yeah, the tests.
It's challenging, and that becomes very difficult for programmers, especially programmers with a lot of experience. I'm trying to get programmers with a lot of background experience, decades of writing, to try to think this way.
Yeah.
Very, very difficult.
I wonder if there's some kind of. Sometimes something I've seen is there's a mindset in there where the test code is just this thing I write once and it's not as important. This is the real code over here, but the test code is second class. And so there's a sort of a suffering and irritation that happens when I have to go change the test code. That feels wasteful. But we need to emphasize that the test code is as important, if not more important, than the production code, because I think it was somebody had some kind of thought experiment. It's like if I had the test code on one hard drive and the production code on another hard drive, which hard drive would I rather fail? The production code, because then from the test code you could recreate the production code. Can't go the other way around. So it's almost, you have to elevate the status of the test code, I think, and help developers, help engineers to embrace it as that's not a cost of doing business, that's an asset.
Right. My challenge is also to encourage them that test codes are good.
Yes.
They like to, I'm going to sit there and test it, and sit there and play with it. It's tested, but there's no repeatability in that test.
Yep.
So that's also education.
Yeah.
That's, I think, another challenge to convince people that writing tests that you check in is useful.
Yes. Yeah. That's a big deal. Yeah. There are things that feel fast, and there are things that are fast, and they aren't always the same thing. And helping people to see that, it's like playing with code without constraints feels fast, but you're building a house of cards. All right. Anything else? Thanks so much for your time and attention.